Okay, so let's get started. I have talked for a long time, so now we can just start with the software and start working on a specific example. So what we are going to do is we're going to learn the basics of the software, where to find things, the user interface. So go to your desktop or to your menu bar or your search bar and look for the OLI Studio 11.5 and open it, please. So that should open a new window. That should be your base. This is how the software should start. And if it doesn't use your whole screen, just maximize it. So this is how it looks. First of all, you will see that there are different sections in the interface. You will see a menu bar that you're familiar with, menu bars. Then probably you will not see this or see this. I'm not sure if you will see the calculation status option there. But then you will see another bar here where is the toolbar, is where basically we want to make quick selections for our models. We have the navigator panel. In here you'll see all the icons, all the calculations that you start adding to the file. Then you have the actions pane. In this actions pane, you will have access to all the different objects that you can use based on the license that you have. So if you were to have a stream analyzer and corrosion analyzer, you will see 1, 2, 3, 4, these 4 icons. And this is important for me to know from Mariana and Joaquin. I just want to make sure that you see these 4 icons. This will tell me that you have the stream analyzer and the corrosion analyzer.
Yeah, we see 4 of them.
Okay.
Yeah, we see the stream, at mixer, at water analysis, at EBS.
EBS, okay. You probably will not see brine, oil. This is for the ScaleChem. And it's okay. We're not doing training for this. But I have access to all of the different objects. So you will see this for the ScaleChem software. So good. That's good. I also need to, yeah, you will have these 4. So then this tells me you have 2 products, the stream analyzer. If you didn't have the corrosion one, you wouldn't see the EBS calculation. And that means that you will have only the stream analyzer. Okay, so then you will see down here, there is a calculation output. This calculation output window is very useful because it will tell you, right? Like the calculation failed, the calculation is completed. It will give you some warnings. Some of them are, you don't understand them. Some other ones are like clearly tell you what you should be doing or what you're missing in your model. The middle here, the middle section of your stream is, it will change once we add an object, but basically you will always see a description tab where you can always add information. And I like to use it a lot because you forget, you forget details. And if you're doing 10, 20, 30 calculations, and then you want to go back and remember what you did, this is very useful to have written something there. And then you have the summary table. This summary table is also very nice because you will see quickly the results if you're having what you need, etc. Okay, so the first example that we're going to do today is going to be an isothermal calculation. We're going to learn how to set up an isothermal calculation here, and learn that the software by default doesn't calculate or doesn't include redox reactions, and that we have to instruct the software to do that. So the first calculation is going to be called elemental iron in a 1 molar sodium chloride solution. Okay. So what we're going to do is, to the right in the actions pane, we're going to add a stream. And to add a stream, you just simply double click on it, on this icon. And you'll see that you will have a new section here. It's called the definition. Okay. You also have a new stream, a new icon here. This icon represents, is going to incorporate all the parameters, chemistry, conditions, everything. And we can always rename it. So you can rename it by double clicking on it, by right clicking on it and click rename. There are options. So let's rename these isothermal calculations. Isothermal calculations, and here in the definition tab, and let me know if you can see my screen very well or not, if I have to increase the numbers. So the software, one thing it does is, you'll see here in the menu bar, it has some default settings. So the software will always turn on or use the MSE framework for all the calculations. That's the default MSE, mixed solvent electrolyte. Okay, and it's okay. We can use the MSE framework or the AQ framework here. It doesn't, for this example, it's not relevant. You will see that you'll have something turned on here. These are the phases: liquid 1, vapor, solid. That's by default. Okay. The water also adds the water. The software also adds water by default as an inflow. It's always going to be the case. We are an electrolyte software package and we need water. So we put it by default so people don't forget. There are other settings: temperature and pressure, 25 degrees C and 1 atmosphere. This stream amount is the addition of all the inflows that you add here. So you'll see that currently is 55.5082 moles of water, which is equivalent to 1 kilogram of water. That's why if we add here in our inflows NaCl, okay, if we add in our inflows NaCl and we say this is 1 mole, this immediately is going to be 1 molal of sodium chloride, right? Because it's 1 mole in 1 kilogram of water. And you'll see that now the stream amount is adding up these moles here. So that will be your total amount of material that you have in the system. Okay. So in this case, we want to do just that. We want to calculate the elemental iron in 1 molar sodium chloride. How do we enter the elemental iron? We simply type Fe. Enter, and we are going to enter a value of a mole, 1 mole. Okay. Now, again, the calculated stream is here. Every time that you see white cells in the software, that means that you can edit. You can always add, delete, change. Yellow cells mean you cannot edit anything. They are as they are. You cannot change naming. You cannot changes or delete. You cannot make any of those changes. Green means is being calculated by default. But you can always override that. You could put 100 here and you could override it. But at the moment, we're just going to leave it as is. So this is our system. We're going to save this file. We are going to save this file as training day number 1. Look for a specific folder where you want to Save your file. I'm going to save it under this file here, where I'm going to say is this is the corrosion model basics training day 1. Okay, so I'm going to name it, and that's it. That's all I need. Now we have specified the system. We have said how much mass, the conditions. What we want to do is to expose this 1 mole of iron, elemental iron, in a 1 molar sodium chloride solution at 25 degrees C and 1 atmosphere. Okay, and that's it. So how do we do a calculation? So you'll see here to the right, there is a button. It says add calculation. And there are several options. So you could do a single point, a survey, a chemical diagram, stability diagram, and a corrosion rate. We are going to learn how to do single points, surveys, stability diagrams, and corrosion rates. If you're interested in the chemical diagram, I could cover it, but I can also give you some content so you learn how to use this specific tool here. For now, the single point, if you click on single point, you'll see that there is sub-calculation under the isothermal calculation stream. Everything carries down. So if you selected the MSc framework, if you selected specific units, all of those are going to stay constant or the same. And if you make changes at the stream level, they will reflect at this sub-calculation level. So what I want to do here is, let's rename this single point. Let's just rename it 1 molar sodium chloride solution. And you'll see that now you have something different here. You have selected the type of calculation, but now you have a calculate button. And this calculate button, you simply, as long as it's green, that means that you're good. You can go ahead and calculate or run this calculation. And this is what I was saying. The calculation output is saying that you were successful at this. We are also saying to the right in the summary, we are saying what type of calculation we did and what conditions. And this is important. Phase amounts. How much aqueous phase you have in your system, how much solids, the pH of your solution, the ionic strength, density, etc. I'm sorry with I don't know what's going on with my Teams. Let me just quit it. Okay. So now that was an isothermal calculation, and I will not spend time on explaining every single one of them, but I want you to be aware that you are not limited to isothermal calculations. You are also you can also do bubble points, dew points. Like if you want to calculate the dew point temperature of a condensate stream, you can do vapor fraction, precipitation points, compositions, autoclave calculations. And if there is no a calculation that is good for you here, you can always create your own calculation using the custom calculation. So I use it a lot, for example, to understand the solubility of a gas in water or in a brine. I use it a lot for that. So you can set up your own. Okay. So once you calculated this isothermal 1 molar sodium chloride and 1 molar iron, you can analyze the results going to the report. When you go to the report, you will see several tables. If you scroll down, we have several tables here available to you. If you don't see the results you want, you can always customize this view. If you click on the customize button, that will open a new window, and it's going to tell you which tables were enabled and which tables were not. And you'll see that, for example, if you were interested to know partial pressures, which we will not have because we don't have a vapor phase, or the activity coefficients, or any other value. For example, what else? The species K values. You can add those to your report and click OK. And in here, you'll see a summary again of what you did, the properties of your liquid 1 phase. Now, every time you say liquid 1, and this is a nomenclature that we have at OLI, and it can be confusing in the industry because liquid 1 in other industries mean the organic phase. But in OLI, liquid 1 phase means the aqueous phase. It's always the electrolyte phase, the water-rich phase. And in here, you'll see the pH, ionic strength, all the different properties. You will see the solid properties as well. You will also see thermodynamic properties. I like this table, the total phase flows amounts. I like this table because you can understand in moles or mass or volume the total and how much you have in each phase. So you don't have to mentally do changes or calculations in your head, right? Okay. Scaling tendencies, this is relevant when we're talking about scale prediction. In here, we don't have any issues with scaling tendencies. This is a table which is really important to understand, and this is the species output true species table. This is the speciation table. The software is saying how much of each species you have in each phase. And of course, in here, well, the sodium chloride is just totally dissociated, right? It went into the liquid phase. There is not a solid phase. And you know that you put elemental iron, and all of it is in the solid phase. Notice that in here, nothing is happening with the iron. It's not oxidizing, it's not reducing, it's doing nothing. It's basically an inert. But we know that if you put a piece of iron in water with sodium chloride, it should corrode. So in here, what's happening is that the element, the oxidation state of that elemental iron is remaining the same. There is not an oxidation change. We have not specified a change in the oxidation state of iron, elemental iron. Okay, so that's what we're going to learn next in the next hour, how to specify oxidation states that are relevant for corrosion studies. Okay, and how we can do it with the redox button here. Okay. So I see that it's the top of the hour. I'm going to save. Please save the file. This is just an isothermal calculation, but we are going to use it for the next example. So let's take a 6-minute break. We can come back 6 minutes after the hour. And then we can continue with our next example, which is setting up redox reactions.